Okay, so in this video, we'll be learning about the various vehicle resistive force that act on a vehicle and we'll be simulating them in Simulink software. So let us first understand what are the various forces that act on a vehicle. So there are basically three types of resistive forces. First is the rolling resistance, second is the aerodynamic resistance, and third is the gradient resistance. Rolling resistance is an effect due to the frictional properties of the rubber and the road. The second is the aerodynamic resistance, so which we are all familiar with. And the last one is the gradient resistance. So imagine that your car is traveling up a slope, so you feel some type of resistance acting on your car. That's exactly the gradient resistance. So what are the formulas for these resistive forces? First is the rolling resistance. The rolling resistance is given by F subscript R, which is equal to CRR into mg into cos theta, where CRR is the coefficient of rolling resistance, m is the weight of the car, g is the acceleration due to gravity, and cos of theta, where theta is the inclination. The second is the aerodynamic resistance, given by half rho CD AF into V square. So rho is the density of the air, CD is the coefficient of drag of your vehicle, AF. So one thing to keep in mind is that AF is not the entire area of your car. It is only the frontal surface area that if you make your car in a standstill position and you look it from the front. So the area that is projected, that is your frontal area. Where V is the velocity of the car in meter per second. The last is the gradient resistance. It is given by mg into sine theta. The terminologies which I explained earlier. So the total resistive force is the summation of Fr, Fg and Fa. So with that being explained, let us jump right into Simulink and simulate these resistive forces. So step 1 is that we have an input for the velocity. So there are two types of inputs. First is a constant input and second is a variable input. Let us take a case for both of them. So first let us just make a constant block. I'll just yes, and we have a constant block. Also import from workspace block, from workspace right here. I'll explain why we are importing this. Now we have to import a switch. So physical switch. We will go to signal routing and we can search here for a manual switch. Yes, that's right, a manual switch. Just import it into your work area, connect both of them, that is the constant block and the from workspace block. Let us name this block as velocity in kilometers per hour. Velocity in kmph. After that, let us import a gain block. So we'll convert the kilometers per hour into meter per second. So the constant that we have to multiply with, constant multiply with is 5 divided by 18. Okay, and let us connect this with a go-to block. Connect this. Okay, name this tag as velocity in mps, that is velocity in meter per second, and change the tag visibility to from local to global. So with that being done, let us model the rolling resistance forces. So we can import a new constant block, or one way to do it quickly is that we already have a constant block here. So just press the control key and left click and drag to copy it. Let me name this as the mass of a vehicle. So let's say mass, and in the brackets let us give it kg and change this to m. Okay, so we have not yet defined what these m and the variables that we have not yet still defined. So we'll do it in the end. So don't worry about that. Also, just make a copy and let me give this a name of g. That is, we have this 9.81 meter per second square acceleration due to gravity. Change the tag name. Let's say acceleration due to gravity. That's right. Now we need a from block. Import it from the library browser and change this name to grade. Okay. Yes. Also, we have defined the coefficient of rolling resistance. To make a copy of the constant block, change the name CRR, that is the coefficient of rolling resistance. Click OK. We can rename this as coefficient of RR, that is the rolling resistance. Okay, now we need to import a trigonometric function block. So in order to give a cos, so we know the formula Fg equal to CRR into Mg into cos theta. Connect this to grade block. Import let's say product. Yes. We have 4 entities 1, 2, 3 and 4. Double click on the product block and change the number of inputs from 2 to 4. Click OK. Let me just expand a bit. Yes. Connect the mass M, G and cos of theta, and yes, coefficient of rolling resistance. Now with that being done, let me just copy the go-to block from the velocity, connect this and let me name this rolling. Okay, so we are going to access this entity afterwards. LING, and the tag visibility is already global. Okay, now select all of them and let's create a subsystem. From this there is an option for subsystem. Just expand a bit so that we can see it clearly. Okay, and double click and let's name this rolling resistance subsystem. Yes. So let us go to MATLAB and input the variables. Okay. Yes. So the first variable that we need to input is the density of the air. So let me name this rho, and the density is given to be 1.225. Yes. Then the frontal area, name this A, and the value is 1.8585. Alright, so these values are of an actual Formula electric car. So these are not some hypothetical values. So what we are doing here is pretty much a realistic simulation. The coefficient of drag given by CD, and the coefficient of drag is 0.9. Then comes the coefficient of rolling resistance, that is equal to 0.015. Alright, the mass of the car will be 903 kg, and for simplicity purpose, let us just imagine that our car is running on a flat terrain. So the theta, that is the angle of inclination, we give it as 0 degrees, be it degree or radian, it doesn't matter. Also, let us just give the acceleration to gravity as 9.81. Okay, so we have the variables in our workspace already. Now we want to input velocity, but it is not constant. It is a variable which it will vary with time. So I have data in the form of Excel, that is the time versus the velocity in kilometers per hour. Don't worry, I'll link all these sources down in the description. So I have this here, resource. Okay, let me select this folder, and in the track there is a CSV file. Let's click and drag it here. So we have to input, or rather import, all this data. So the first column shows time step, that is the time in an increment of 0.1 second, and the data goes up till 46.7 seconds. And the left, that is the second column, it gives the value of velocity in kilometers per hour. Let's import this selection and close this tab. Similarly, you also can input a gradient data, that is how your inclination is changing with respect to time. So I have already imported this in the form of a grade data. Let me access this track so that you can view all the values. So let me just type in track and click enter. Yes, so the dimension is 468 by 2 and it is a table. Now we want to assign a variable to all these values. So in order to segregate, and also yes, just one thing to remember these variable names. So the first is drive cycle, the second is where name 2. Go to the end and let me just give this as time. So I write time equal to track dot drive cycle and click enter. In the left column you can see a time variable that is created. The dimension is 468 by 1. Now let us have a velocity, velocity velocity equal to track dot where name 2. Yes, we have input of velocity. Similarly, let us input the angle, that is the inclination, equal to the grade data dot where name 2. Now let us create a matrix of velocity. Let me name this VEL equal to, and yes, time velocity. Okay, and another matrix of grade equal to time and great. So now we have all the data that is required for a simulation. Let me just minimize this and go to our Simulink library. Double click on the velocity from workspace block and name the matrix that you created, that is VEL velocity, and click on OK. So there is no error now. Also double click on it and you can see that all of them is gone. From okay, so this is the grade data. Now let us create a similar subsystem for the gradient resistance. So just click on control and drag it, and let me name this as gradient resistance. Okay. So gradient resistance subsystem. Double click on it and we need to delete only the coefficient of rolling resistance. Delete this signal and change the number of inputs from 4 to 3. Since the formula for gradient resistance is Fg equal to m into g into cos theta, so there are basically 3 inputs. We already have m, we have g, and we have the gradient data. Let me double click on the cos and change it to sine. Say apply. Okay. In the go to block, let me name this as gradient. The tag visibility is already global. Click on apply. Say OK. Go back. Now is the time for aerodynamic resistance. So just control and drag it. Let me name this as aerodynamic resistance. We have aerodynamic resistance subsystem. Double click on it, and we need to delete all these blocks for now. Let me just search it. Alright. Now that we are in the aerodynamic resistance subsystem, we need to delete all of them. Let's press delete. Drag in a new constant block. Okay. We need to copy it. 1, 2, 3. Yeah. So there are total 4. The first one, change it from 1 to 0.5. Second, give it row. Okay. Then the third one is going to be the frontal area, so that is A. And the fourth one is the coefficient of drag, that is C and D. Not this one, just C and D. Click on OK. Now we need a velocity input, so I'm going to drag a from block. And we already have a go to block, so we will just double click on it and search for velocity in meter per second, that is VMPS. Click OK. The velocity that we are getting here, now we need to square it, since the formula is half rho CD A into V squared. For squaring, we can go to math operations, and in this there is a math function. So just drag it here, connect the velocity input, double click on it, and we need to change from function of exponent to square. Okay, now we need to import product block. There are total 1, 2, 3, 4 and 5 inputs, so we need to have 5 number of inputs. Click on OK. Expand this block a bit. Now connect 0.5, row A, CD, B squared. Okay, so now we need a go to block. Go to. Connect the output from the product block. Change this from the tag to A to aerodynamic. And change the visibility from local to global. Click on apply. Now we have all our resistive forces ready in our subsystem. We have imported for velocity. Now we need a similar output for gradient. What we can do is select all these blocks, click on control and drag it to make a copy. From the annotation block, let me name this as a velocity. So I'll just click here and let's say this is the velocity data input. Change the font size to bigger, let's say 24. Great, and copy this. Just change this to gradient data input. Great, so now we need to change this block from velocity. So just delete it completely and name this to gradient inclination bracket degrees, and from workspace block change this to grade. what was the, so we are still getting an error. So let me just see what name did we give for the gradient data. So okay, so it is GRAD and not GRADE. Just change this from GRADE to grad. Okay, apply, and yes, so that is what VMPS, and change this from VMPS to, you have to change this to grade. Great. Also, we need to change from degrees to radians. So the conversion unit is pi divided by 180. Click on apply. So we are pretty much done with the input. Now we want data visualization. For that, we will create separate visualization blocks for rolling resistance, aerodynamic resistance, and gradient resistance. Also, we'll sum up all of them to view the total resistive forces that will act on our car. So let us do the second part first, and import from blocks. So we need 3 from blocks corresponding to 3 different resistive forces. Let me just copy this, 1, 2, 3. If you remember the name, the first one is rolling. Double click on it and type in rolling. It must pop here. Yes. Okay. Double click on the second one. Second is aerodynamic. The third one is gradient. Was it grade or was it grade? Okay, it was grade. Click on OK. Just to verify, just go to gradient. Okay. Oh, okay. So that is gradient and not grade. Just double click on it to change the gradient. And okay. Import a sum block. Let's say sum. Okay. Import a sum block. We have this in the math operations. Right now the inputs. Okay. Change the number of inputs from 2 pluses, and let us add one more plus to give 3 inputs. Connect all the 3 from blocks to this summation, and once that's done, let us input a scope block. So yes, the scope, and connect it to the output. Also select all of them and create a subsystem. So I'll just right click on it, selecting all of them, right click on it, create a subsystem. Just expand this a bit, and I'll name this subsystem as data visualization subsystem. We need to now this step is completely optional. If you need to view the resistive forces separately, you can do that. Just click on from and change this name to, let's say, aerodynamic. The first one is aerodynamic. Control press and drag. The second one is gradient. The third one is rolling. Import a scope block. Here we have it. The scope. Connect this to first one. Control and drag. Control and drag. Connect all of them. And we are pretty much done with our modeling. So just make it full screen. You'll be able to see it. Just take this side. Okay, let us run this simulation. So if you remember, the time that was that we input, that we had in our variable, was maximum of 46.7. So I'll change the simulation time for now to 46.7 so that we can easily see what data that we had. So 46.7, that's a decent amount of time for a simulation to run, and let's just run our simulation. Okay, so one thing I forgot is that we need to change the switch from constant velocity to a variable velocity. So just double click on it to change the switch. Let us do the same thing for the gradient data. So the simulation time is 46.7 seconds and click on run. Great. So let us have a look at our resistive forces. The first one is aerodynamic resistance. Double click on the block, in the scope block. Okay. So this is what the graph of our aerodynamic resistance looks like. So since our velocity is variable, we can see that it is a varied graph and it follows a polynomial 2 function. Here we can see that around let's say 13 seconds or 12 seconds, the maximum aerodynamic resistance is achieved, that is around 7,000 newtons. Similarly, you can see the various dips and peaks for aerodynamic resistance. Let us have a look at our gradient resistance. The gradient resistance, the top term, that is the maximum gradient resistance, is achieved around 16 seconds and it is close to 450 newtons. Have a look at the rolling resistance. Also, the rolling resistance has a maximum value of say 132, and it is the maximum value is reached multiple times, that is at t equal to 7 seconds, t equal to say 11 seconds. You can see here as t equal to 38 or 39 seconds. Now that being done, let us see the total, that is the cumulative resistive forces that act on our vehicle. So go into the data visualization subsystem and double click on the scope block. So this is the plot of the total, that is the cumulative resistive forces. We can see from the data that at around 12 seconds, the vehicle has a maximum resistive forces that is greater than 7,000 newtons. So this data can be pretty useful to calculate the various the reductions for your powertrain, the minimum amount of force that you need to overcome in order to wait for your vehicle to not stall. So this was it. This was a quick look at the vehicle resistive forces and how do you simulate them using Simulink. I hope you find this video useful, and if you did, make sure you like the video and also subscribe to my channel. See you next time.